Need to prove by induction this statement for all integers n. Let's begin. Proof. Step 1. Put m is equal to 1, right? Let's focus on LHS. What we're gonna do, we're gonna sub m is equal to 1 in the last term to check whether when m is 1, are we getting 12 or not. So let's start. So 5, 1 plus 2 to the power of 1 minus 1 plus 2 times 1, right? So it's 5, 1 plus 2 to the power of 0 plus 2. That's 5 times 2 plus 2. That's equal to 12. Now what's RHS? Here you put m is equal to 1. So it's 1 plus 1 plus 6 plus 5. 2 to the power of 1 minus 1. So it's 7 plus 5. 1, 2 minus 1. So that's 7 plus 5 times 1. So that is equal to 12. That gives us LHS is equal to RHS. This implies M is equal to 1. M is equal to 1 wholes. Fine. Now let's go ahead. Step 2. Assume that the given statement is true for M is equal to K. It's 12 plus 19, so on, plus 5, 1 plus 2 to the power of K minus 1 plus 2 to the 2 times K is equal to, let's label it as star. Now we will assume in step 3 that the given statement is true for M is equal to K plus 1. We will include the kth term. This will be 2k plus 1. Okay, and that is equal to k plus 1, k plus 7 plus 5 times 2k plus 1 minus 1. So we required to prove this. Before we begin the proof, let's look at the RHS term in the left hand side, because this question has a lot of terms, right, to be rearranged. So what it gives us, let's first focus on k plus 1 and k plus 7. So what it will be, k square plus 7k, k plus 7. So that's k square 8k plus 7. Next is 2 5 times 2k plus 1 minus 1. That's 5 times 2k plus 1 minus 5. Now we need to get this polynomial and something like this, right, to prove our given statement. So let's start. Now let's consider LHS. So on LHS, look, 12, 19, so on till 5, 1 plus 2k minus 1 plus 2k plus 5, 1 plus 2k plus 2k plus 1. Okay, so this bit is straight away from the left hand side of this, right? So we're gonna use this. So from star, what do you get? K k plus 6 plus 5, 2 to the power of k minus 1 plus 5, 1 plus 2 to the power of k plus 2 times k plus 1. So we are getting this from star. Now let's open the brackets. What we get? K square 6k 5 times 2 to the power of k minus 5, 5 plus 5 times 2 to the power of k plus 2k plus 2. Now this and this is gone. Now k square, right? So there's just one k square. Then you have your 6k over here and you have 2k. So that gives you 8k, right? And then you have a plus 2. Let's put plus 2 over here. And you have this term and this term. So if we write them as it is, let's write them as it is. We're going to handle them in the next step. Now 5 times 2k and 5 times 2k. So this is k square 6k plus 2. This will be 2 times 5 times 2 to the power of k, and that's k square 8k plus 2. This is 2. So this is basically 2 to the power of 1, right? So 2 to the power of 1 and 2 to the power of k. So this becomes 2 to the power of k plus 1 times 5. Now let's have a look. We have this thing is there. This thing is we have got. We have this term and this term as well. Right. Now we just need to adjust this negative 5 and 7. So I'm going to add and subtract 5. So this gives you k square 8k plus 2 plus 5 plus 2k plus 1 times 5 minus 5. So here is the 5 getting added up. Here the 5 is getting subtracted. Now let's handle it further. K square 8k plus 7 plus 5 times 2k plus 1 minus 5. Now just see from here, this is equal to product of k plus 1 and k plus 7, right? And here this is also same. So can I pull out 5? I'll get the second part. So hence our result is proof. So this is k plus 1 and k plus 7 plus 5 times 2 to the power of k plus 1 minus 1, that is equal to your RHS. Therefore, M is equal to k plus 1 is true. M is equal to k plus 1 is true, and hence what we can say, therefore, given statement is true for all natural numbers M.